No, I
Um,
think tracking,
right?
yeah.
But the point is, okay, you're working in 3D space and you're just saying any two vectors, right? And you
Right.
just want to figure out what the angle in between them is. Maybe let's call
Mhm,
that theta.
mhm.
And this isn't too crazy or anything. Uh, Remember, we said that. Okay, so maybe I'll ask you the question. Yesterday, we were given some tools with, some tools have been introduced with this class that can let us find the angle, or rather, some trig expressions involving the angle. Do you remember any possible tools that might come to mind for this?
Yeah, I don't remember the name. So it's the magnitude XY cosine angle, or
Yeah,
maybe it's
yeah, no,
vector
that's exactly
XY.
right, actually.
Okay, okay, okay.
But do you remember which product it was? That particular one with cosine?
Which product?
Yeah,
No,
dot
no,
product or cross product. Do you remember which one?
yeah, I'm afraid I don't.
That's
I
okay.
think
It's okay.
yeah, I don't remember, I'm afraid.
Sure. Memorization isn't the be all end all, but sometimes it helps to work on that skill over time, just so that you can remember it quickly without having to rack your head too much. But
Sure.
yeah, so x dot y is equal to magnitude of x, magnitude of y, and cosine of the angle between them, right?
Right, it was dot product. Okay, yep,
hmm
yep.
Whereas cross product would have I don't know if you've seen this yet, but cross product would actually um, talking strictly about the magnitudes. The cross product uh, is very similar, but with a sign. If I remember correctly, it's something like x cross y. The magnitude of this is equal to x y sine theta, off the top of my
Okay,
head. And this is purposely contrived to be this way, where there's this nice symmetry, right? One is cosine and the other one is sine.
right.
But for now, I would say the dot product is the easiest way to do this. And given any two like explicit vectors, you know vector x, you know vector y, you know the magnitude, and you know the magnitude, right? So that's
Right,
basically just saying solve for cosine theta. So you're going to get a perfectly genuine number that's going to be
right,
between -1 and 1.
right, okay.
Uh, and that's going to be your cosine theta. And you just need to either plug that into a trig calculator to take the arc cosine, or just or you should be able to work it out just
Yeah,
by looking at it.
this is a unit circle thing.
Yeah,
I
exactly.
believe this class has a no graphing calculator rule, so I think everything will be
Yeah.
within
I mean, a four
the
function
unit circle.
calculator should have arc cosine as
Sure.
well. But just to sort of remind you, if this is 0 degrees, um, cosine is excuse me. Right. So these, everything within these two quadrants are going to be sort of your acute angles.
Yes.
Um, and over here are going to be sort of your obtuse angles. And then if it's perfectly in between, that's orthogonal. So you basically go and calculate it out, and you just have to figure out what that angle is. So if this is 0 and this is pi, yeah, and keep in mind 2 pi on the unit circle is the same thing as 0. You can basically just go ahead, solve for theta, and hopefully just see what you get.
Okay, why is quadrant 4 an acute angle?
Uh, yeah, that's a reasonable question. How do you put it?
Is it just
So
because everything's rotated, so we're only using that coordinate
yeah, no,
quadrant?
that's a perfectly reasonable question. But the idea here is if you have a really small angle like this, let's say that
Right.
this is your y and it's fixed to be horizontal for the sake of convenience, and this is
Sure.
your x, right? As x gets as you sort of swivel x around, it gets larger and larger and larger and larger and larger, right? Until
Yeah,
x
yeah.
finally reaches over here.
Right.
And at this point, it would be 180 degrees or pi radians, perfectly opposite. And the
I see.
idea is if x goes beyond here, for the purpose, not for the purposes of the unit circle, but for the purpose of calculating the angle between them, if it
Right.
gets there, you may as well just take the smaller angle like that.
Okay,
You see
I
that?
see that now. Yep, I do
Yeah,
see that
that's
now.
the idea. That's the idea.
Okay, yeah, that makes
Because
total sense, yeah, because
yeah,
you don't wanna go past 180, so if you go past 180, then you're pretty much flipping it over and
exactly.
then
And you may as well just
taking an
use a
angle from
smaller
that.
angle then, right?
Right, exactly.
It's
Okay, I
like,
understand that now.
the angle between these two vectors is 270 degrees. Like, why would you say that? Just say
Yeah,
90, right?
right.
But that's the
Okay.
idea. So, would you like to do a sample calculation, or do you think you've got this?
No, I got this. This
Great,
one makes sense as you walk through it.
great.
Yep.
And just a reminder, as a shortcut, if you get that x dot y, is equal to, if it's straight up equal to 0, that's going to be your cosine theta. That tells you right away that theta is going to be 90 degrees. And well, this is orthogonal, right?
Right, right.
My point is, you don't even have to do arc cosine if you see a 0 here. You should just know right away that that's what orthogonal means.
Yeah, absolutely.
Okay, cool. Alrighty, let's look at the next one. The next one is just a literal
Yeah,
computation, right?
yeah, that we're good. We're just going over a very simple cross product for
Yeah,
that one.
just go straight forward through the cross product. Do you want to do an example, or do you think you're good? Because this is like
No,
the most.
I definitely know I'm good on that.
Gotcha. That's like the most straightforward. Like, just
Sure
do
is
the
super easy.
computation,
Yep.
right?
And
Uh,
okay, so for number 6, right?
mhm.
I was taught to do this. Is this where I'm doing the matrix where I am taking out, or is that cross product? If
The cross product is the matrix where it's
the
like
cross
where
product,
it's ijk, and then it's I think it's x1, x2, x3, and y1, y2, y3 for
okay, right?
vectors x and y. I'm
Yep, that's
going off
what I'm.
memory here, so you definitely want to check your
No,
textbook,
no, 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 this is
right?
exactly yep, no, this is what a yeah, so that is cross product. So this
Yeah.
for dot matrix is just I'm pulling the whole numbers off of the letters to use them as the vector and then calculating it from there. Is that correct?
I'm having a little
So
bit of difficulty parsing that explanation,
sure. So
but
yeah, so
just to remind you,
for I'm sorry, yes. I'm sorry. So, let's say if I had a different problem. So let's say I had 6i minus 12j minus, I don't know, 20k, right?
6i minus
Yep.
12j
Yeah, I'm
minus
actually not going to
20k.
go through the full computation. I'm just pulling out
Sure.
random numbers. So what I'm doing for x for the vector x is that I make it a vector of 6, comma negative 12, comma negative 20. Is that the
Yes.
methodology I'm approaching this?
Sure. I almost
Okay.
hesitate to call that methodology because this is really
Okay.
just a notation change.
Sure,
This
it is.
on the left and this on the right carry the exact same information, just one uses the IJK notation and the other uses brackets.
But it would be proper to if I want to just take the vector and then do the dot product, v dot product w, that I turn it into pure number vectors, right? Change the
If
notation
it
and then
helps
do it.
you, that's purely an organizational thing. If that helps you
Gotcha.
get the right
It
answer and not make mistakes, I say go for it.
it does
Uh,
because we use a lot of IJK, and as you
sure.
saw, I almost did it a matrix, so
Okay,
putting it
sounds
in
good.
that format might help. So I
Gotcha.
wanted
So
to make sure I was going the right
yeah,
way.
I think you just gotta really, as you work through this, just really make a big deal and remind yourself which one is dot product and which one is cross product.
Sure.
Okay.
Okay. Yeah, then completely good with this. I
Right.
know how
So
to
then,
do this one.
yeah, and just to be clear, right. So if I gave you some other numbers for y, I don't know, 1, 2, 3, the dot product between x dotted with y is 6 times 1 plus minus 12 times 2 plus minus 20 by 3. Yeah. So
Yep.
dot product, to me, dot product is the one that is simpler because
Right.
it's a little bit of multiplication and addition, whereas the
Yeah.
cross product is the kind of a pain in the butt, and you got to do all this stuff with matrices.
Right, with a sign change, and, this one
Yeah,
just
the
has
sign
very
change for the middle one.
yep, and this one just has a very simple addition, multiplications and addition.
Yeah, and on my end, as someone who's helping out, I don't think that there's anything I can necessarily say to get the computation drilled into your head, right? I think that just
No,
requires a little bit of algo grease and practice for the cross product.
it does, but
Um,
helping differentiate between the 2 will help with memorization of the whole, which would
sure. Yeah.
so yeah,
Okay.
this is great.
Move on.
Yep, I'm good.
Okay. Oh, I gotta zoom in for this one. I feel like I'm getting old. My eyes are not as sharp
Yeah,
as
I
they
know,
used to be.
my eyes are getting tired too. I was like, "Oh, no."
Okay, so what is it asking us? Several unit vectors are in the not in three-dimensional space, but just in two-dimensional space.
Right.
Okay, XY plane. Using the geometric definition, the following
Positive,
dot products.
negative, 0. This feels like the acute obtuse,
Yes,
orthogonal, only
exactly.
it's asking in the positive, negative, or 0.
Yeah. So I think we should talk a little bit about uh how do you put it? Just kind of a little bit of motivation. Oh my goodness, this new pen is so much nicer than the old one.
Is it does it feel good? That's awesome.
Yeah, like it actually brings me joy just when writing. But motivation for the I guess the dot product, the general idea is it tries to capture a notion of how similar or how aligned two vectors are. So the idea is if you have two vectors that are just straight up in the exact same direction parallel, x and y, the dot product is going to be positive, and it's also going to be maximized, right? They could both be in the positive direction of x. They could both be in the negative direction. It doesn't matter. It doesn't matter objectively where they are in the xy plane. It just matters how they are relative to each other. And if they're parallel, the dot product is positive, and so this is a positive dot product, and it also happens to be maximal value. Right.
Okay.
And you can think of that because the angle between these two, I drew them separately apart, but the theta between them is equal to 0. And x, y, cosine of theta with theta equal to 0. Well, then cosine theta just becomes equal to 1. So all you're left with is the magnitude of x and the magnitude of y.
Right.
And
Okay.
you remember
Yeah.
that cosine theta, the maximum value for cosine theta is 1. So this is
Right.
basically saying this is as big as it can be, right? When
Okay,
theta
that
is equal
makes
to
sense.
0. That's
Right.
why the dot product for things that are parallel to each other in the same direction maximizes it. But the idea is that when, let's say x is tilted a bit in this direction, right? Let's say x looks like this and y looks like this. Yeah.
Yeah. Yeah.
And I could draw theta like this. Well,
Right.
they're still vaguely in the same direction, right? X isn't in the opposite direction by any means. Like they're vaguely more similar to each other than they are dissimilar. I'm using these words very loosely, but the idea between this is that the cross product will still be positive, but not as large as the initial example. And the way
Okay.
that we kind of see this a little bit more precisely is when you have x, y, cosine theta. Now this theta is a little bit smaller. Sorry, now this theta is non-zero. Let's say roughly, what does this look like to you? Maybe 60
45,
degrees.
30, 30, 60. Yeah.
Yeah,
Somewhere in there.
I'll call it 60 degrees just for the heck of it. Okay. So then
Okay. Sound good.
cosine of 60 degrees. I should know this. Is it 1/2 or is it √3/2?
Uh, uh,
Yeah,
so
the sine of
three
30 is a half. Cosine of 60 is √3/2.
root
Sorry, so
three.
it was 1/2. So this is 1/2. Whereas before it was 1, this is now 1/2. So you can kind of
Okay.
see why the dot product, why this thing is smaller than this thing.
Okay.
Because the
Yeah.
angle was 0 over here and the angle is 60 over here.
Right.
You kind of see that? So they're still in the same direction, so it's still positive, but the dot product
Right.
isn't as large as it was before.
Yes, I do see that.
Make
Yep.
sense? Yeah.
Yeah.
And now I'll add in an extra tidbit. Hopefully this doesn't make things too complicated. But in fact, if you sort of rearrange these terms a little bit, this is equal to x cos theta
Okay.
times the absolute value of y. And remember from yesterday in our discussion of the projection, x cos theta in this situation is basically the magnitude of the projection vector, right? So this
Oh,
is the
right. Right.
projection.
Right.
So
Oh,
in some
okay.
sense, the dot product is almost you can think of the dot product as either x y cosine theta directly,
Right.
or you can think of it as sort of the magnitude of the projection times y,
Okay.
magnitude of the projection
Yeah.
times the
I see
magnitude of
that.
y. Yeah. So, and the idea here is because of how right triangles work. Yeah. The fact
Right.
that x is at an angle from y means that the projection isn't going to be as large as x itself. Hopefully that intuition makes some sense.
It does. It does. I'm starting to slowly like understand how
Yeah.
they're connected.
Okay. So then now we go to a case where this is y and this is x, and they're perfectly at 90 degrees from each other. What if we've talked about this one in I think one of the previous problems, but what's the dot product going to be when these two are perpendicular?
Uh, this is this the one that canceled out, right? No, this is.
not quite cancellation, but kind of a similar
W
concept.
right, it's a rule. Is it 0?
It is
No.
zero. It is zero,
Okay, okay, okay.
right? So this
Yeah.
particular case, we know that it's zero, um, because cosine of 90 degrees is just zero.
Oh, right, yes.
Yeah, not crazy.
Yeah, no, no.
Yeah, and sorry, excuse me. Yeah, so it doesn't matter if x is pointing up or x is pointing down, as long as it's a 90-degree angle, it's going to be a big fat zero.
Right,
And okay, to do sort of your last case, well, I guess last two cases. Um, if it's pointing like this, it's greater than 90 degrees, but less than 180.
right.
Uh, at this point, they're sort of more different than they are alike. And x dot y is equal to x, y, cosine of, oh gosh, help me here. I'm going to call this 120 degrees, right? Theta is equal to 120.
Okay.
And this will turn out to be negative a half, if I remember correctly. Uh,
Yeah.
wow, my trick is really
Because
rusty.
it's a reflection off the quad 1, so right?
Yeah,
And then, yeah, and then the reflection of
right.
30
It's a
degrees would
reflection
be
of whatever
okay,
this one was. And if we said this one was a
it was
half,
1/2. Right,
right, this one ought to be negative one half. But the idea here is the dot product is sort of capturing the information that they're more different than they are alike at this point. And to sort of do the
right,
final one, if this is y and this is x, and they're in opposite directions, well, x dot y is equal to x, y, cosine of 180, and that's just negative 1.
right.
So
So,
the
yeah,
thing that might be a little bit tough about this problem is that whereas I made it really nice and easy for you with y always fixed to, be this nice angle pointing off to the right, for this problem, you're comparing all sorts of different pairs, right?
sure.
So
Gotta
if you got
mentally
an angle
rotate.
that, looks like this and looks like this, you kind of just have to eyeball it and figure out, okay, well, is the angle, it all comes down to, is it the angle smaller than 90? Is it 90 or is it larger than 90?
Right.
That's what it
Positive,
comes down to.
negative, or the orthogonal,
Yes.
which lines up with the acute, the yeah,
Yeah.
acute and obtuse.
And
Yes.
just to, as a reminder, if you see an angle that looks like this, it would be, you don't want to talk about an angle that's larger than 180. That's, it's not wrong, but it is kind of silly. If you have an angle that's larger than 180, you would rather just go the other direction to talk about the angle that's smaller than it. Um,
Right.
you don't have to, but I think that makes it easier to think about. So to sort of sum up what we talked about, right? When theta is, I guess it's 0. I'm going to use this notation, right? 0 to 90. Remember, this means inclusive. This means non-inclusive, right? This is a parentheses, whereas that's a bracket,
Yes,
right?
yes.
So that's going to be acute. When theta is exactly 90, that's going to be
0.
orthogonal.
Yep.
Orthogonal. And when theta is from 90 non-inclusive to 180 inclusive, it's going to be obtuse. And these also correspond to acute also corresponds to a positive dot product. This corresponds to a 0. So this is the dot product, and this is the angle. This is obtuse, and the obtuse is going to correspond to a negative dot product.
Okay.
So you can kind of think about this little chart. And, I don't necessarily encourage that you memorize it. I sort of encourage you to sort of understand the reasoning behind it.
Right. No, I do understand that.
Okay, cool, great. Yeah, cool with this?
I'm a golden on this. This really helped.
Yeah, that's awesome. So then we get into slightly more difficult cross products where instead
Yeah.
of just doing straight numbers, now you got some functions. And that might look a little bit intimidating, but just remember that you can treat functions basically the exact same way.
Yeah, yeah, so for this problem, I have a problem with logarithms, and I kinda get a little confused. Is there an example that we can do that uses logarithms?
So
Or the E?
these are exponentials, but they're
Excuse me,
similar, right? One
exponential.
is the inverse
Yeah,
of the other.
right.
Um, yeah, I guess we could. Let's maybe instead of So how do I put it with choose a reasonably different example? So this requires you to remember the rule, our exponent rules, where if you have any base, we could call it a or we could call it e, but the idea is that e to the t times e to the minus t. When you do this together, you can combine them and just add the exponents up. So this is equal to t minus t, which is just equal to e to the 0, which is a big fat 1.
Okay.
Um, Other than that, this becomes it's a pretty straightforward cross product problem.
Oh, I guess it is, isn't it?
Yeah.
I guess
Ultimately, you just got
okay.
to remember to do the cross product exactly right. And I do want to remind you with a cross product, just be super sure that remember that what was it exactly? Like it was I x2 y3 minus x3 y2, right? But then the
Right.
j, the middle term, sort of has an extra negative sign in it,
It does.
right?
Yes.
It's like blah blah blah, and then it's minus j, blah blah blah, and then it's plus k.
Yep.
Just make sure to do a couple of examples of those and make sure that you got it down for regular numbers.
Okay.
And then when moving over to functions, it should be much the same. Just remember that you can sometimes get a little bit of cancellation like this.
Right.
I could
Yep.
do a relatively simple example if you'd like. How about if I did an example like what do I call it? E to the t I. It's going to be really simple, right? Plus 0j plus uh 0k. Like I said, it's going to be as simple as it gets. So if this is x and this is y, so y is going to be 0i plus um, e to the minus t, j plus 0k. Okay. If I dot product that, sorry, if I do the cross product routine for this, I hope I still remember how to do this, but it looks like e to the t 0, 0, 0, e to the minus t 0, right?
Right.
So then just doing the cross product thing, it's I
Do you have
hat.
a trick that you use to know where you start? Right.
I
'Cause
mean, it's more
so
of a pattern, right? It's
right.
so you start with I and then you do the
Yeah.
sort of crosses here.
Yeah, but the crosses matter, right? Because if you go left, top left to bottom right,
Yeah,
and
it's like a
then the other
determinant. Do you remember
right.
determinants from matrices? Uh,
Yeah, but not enough to remember the rule that I use
yeah,
to know which one I.
it's these two minus
Right.
these two. In this
Okay. And
particular case, it happens to be 0.
sure. Do you have something that you keep from doing? Because sometimes I will go from, like,
Yeah,
bottom up the other way.
I think you just gotta do a little bit of
Okay.
elbow grease here and make sure you remember the pattern. Make sure you remember the protocol.
Okay.
I have this ingrained into my head. I'm never gonna forget this.
Sure.
But yeah. So
Yeah.
with J, at this point, you sort of have to like pretend you don't see this one anymore and just do e to the t and 0, 0 and 0, which also happens to be just come out to 0.
Right.
Yeah. And then for K, uh, you do this again,
Yep.
you do the cross, and this is going to be non zero with the
Right.
other cross, which is 0. So it turns out that all that's left for this one. So remember, this should have been a minus j, but it doesn't matter because it's
Right.
0 anyways.
Right.
But this turns into k times e to the t, e to the minus t, which is just, this is just equal to 1, as we said earlier. So all you
Right.
get is a k hat at the end.
Okay.
Yeah. Like I said, I can't replace the experience of going directly through and getting a little bit of practice with cross products. So I recommend you
I definitely have
some more
enough
about that.
practice problems to do that, but yeah, this helped clarify kind of you get a little confused with when they start throwing different things at you, so,
Okay, good.
I am good with this one.
Okay, so the next one, uh, interesting. U dot u. Okay, so they don't give you the exact. So what's going on here is they don't give you the exact vectors u and v anymore. They're just
Right.
telling you sort of, kind of what they're how do you put it? Instead of giving you the direct vectors themselves, they give you some of the results involving them, where they tell you u dot v is equal to something. So you know this, you know the magnitude of u, and you know the magnitude of v. And that should be enough for anything involving just dot products. Because Okay, so remember, I'm going to choose a slightly different problem, just one of my own invention, but like 5u dotted with, I don't know, 10u minus 5v,
Right.
right? We said yesterday that the dot product is distributive. So we're allowed to sort of simplify this a little
Right.
bit by writing this as, I guess this is 50 u dotted with u
Right.
minus 25 u dotted with v.
Right.
And we said yesterday that u dot
You
u is just going to be
you
u squared.
yep, which is also a rule.
Um,
Or no, that's for oh, wow.
I wouldn't call that a rule. It's just sort of we're just saying square.
I think I'm getting it confused with, the vector thing where you multiply it by itself and it becomes, 0.
That's the cross product.
The cross product, yes.
Yeah, the dot product when you multiply itself,
It
we call
becomes
that u
different.
squared. But this also happens to align perfectly. Remember yesterday we said it happens to align perfectly with our notion of Euclidean distance, where Euclidean distance is u1 squared plus u2 squared plus u3 squared, right? The x, y, and z components.
Mhm, yep,
Um, and then when you square this, right? When you square this happens to look exactly like the dot product. Remember how I said this was a great big coincidence? It's not actually a coincidence. They chose it to be this way.
you're right.
Yeah. So this is exactly equal to u dot u. You see that?
I do, yeah, no, I
Yeah.
do, and I do remember us going over there, yeah,
Yeah.
I'm
So
just gonna
what
have
the
to elbow read
mathematicians of
here.
the old day probably did was they were trying to come up with a definition for u dot u, and they probably wanted it to line up with the idea of uh, u squared, sorry, the magnitude of u squared, where the magnitude is the Euclidean distance. And I'm guessing that they probably chose the definition to make these things line up.
I see.
Yeah. But then this turns into 25 u dot v. And based on what they give you in the problem, we know all these things. Yeah. Well, they don't give you u squared, they just give you the magnitude of u. But that should be easy enough because the magnitude, again, is literally
Right,
just a number.
right, and
And
you
u
already
dot
have that
v,
number.
literally just a number.
Right, it's just computation at
Yep.
that point.
So this problem just turns into, it's basically one distribution and then one distribution and then what do you call it? Applying the values that they give you.
This does make sense.
Yeah,
I know that I'm gonna have to grind out a few of these. This is not a pattern that's ingrained in my head, so
sure. Uh, yeah, I think the spirit of this problem is that even though they don't give you uh, the explicit vectors of u and v anymore, like in the past, they always told you it was like 5i plus 10j plus
yep,
15k or something, right? You can still talk about some of their combinations like u dot u or u dot v, um, or if they give you these values instead.
right.
Right.
Maybe it the setup like what you said with everything, setting up this problem might be the key to reminding that I'm not messing with the vectors, just more of the proper noun of the vectors, right?
I'm not quite sure what you mean.
I'm just messing with U and V's. I'm not really plugging things in. We have to do the formula, right? You have to distribute,
Yeah, I see
set
what
it
you're
up,
saying. Right.
and
They're
and
trying
and
to
then you
separate the idea of computation a little bit with what the dot product is actually doing. Right. We said
right,
earlier that um, the dot product is basically a measure of how similar u and v are to each other, how aligned they are.
right,
And in this problem, they're not giving u and v individually. They're just telling you, hey, this is how closely aligned they are. They just chose some value for it. And they say,
right.
okay, here's the actual magnitude of here's the actual magnitude of v. And that means we can solve problems that look kind of like this.
Yep,
Okay.
sounds
So
good.
let's move on.
Okay.
So here it's a very it's a okay. Here's another one where it's solving. Sorry, here's one where they tell you so we know what u cross w is. We don't know u and w themselves, but we do know their cross. And now we're given something that looks like I'm going to use different numbers, but like 5u minus 20 w crossed with w. Yeah. So how would
Yep.
we distribute that? And they're asking what this is. They WTF, want to find what this is. So
Right.
similar to yesterday, or similar to the problem above, really. Let's just go ahead and distribute this, okay? How would you
Right.
distribute this?
I mean, just like kind of your foil-ish
Yeah.
method, right? Right. So you have five u cross product w
Hmm.
minus 20 w cross product w, but we know what that last one means.
Hmm. And what is that?
A zero, which
Yep,
would then
I agree.
eventually zero out to 22.
So
20
all
and
that
then
we
minus
have
20.
left is u cross w.
Right,
And
right,
remember,
right.
we know what that is.
And we do know what that is. And then
So
so we
whatever
just
that
have to use
value
a scalar.
is, whatever they give us, sorry, that's not actually a scalar. U cross w. So this
No, but the 5 is a scalar, right?
the 5 is a scalar. Yes, the 5 is a scalar.
Right. I'm
Um,
sorry. So I put the number in for the u cross w because they give it to us,
well,
right? But then
reminder,
oh, I'm sorry.
the cross product takes two vectors and spits out a vector. You're getting mixed up with a dot product, which takes two vectors and
Ah,
spits out a scalar, right? This is
right,
some actual value of a comma b comma c. Well, it's some vector comprised of individual components, right?
right.
Okay. So then once you have that, you can just plug that right in.
Okay, right.
Like, are you looking
Um,
at the actual problem right now? You see
yeah,
how u cross w is actually some
yeah,
straight up vector?
right. But don't you still multiply the scalar across?
You do. You do.
Okay, okay. I'm sorry. Then I got
Yeah.
confused. Yes, then I'm
So then,
tracking.
yeah. So then if this is like 5 times u cross w and I'm saying a, b, c, that just
Yes.
turns into 5a, 5b, 5c.
Right. My mistake. It was not one solid number. It was the vector you
Yes.
plug in there, and then you multiply the scalar. Yes,
Yes.
tracking.
Great. Okay. So now they're asking find a non zero x perpendicular to the vectors. Ah, this is a good one. This is a good one. Do you know what? So they're basically saying, I'm not going to use the specific numbers again, but we have a v and we have a u,
Right.
right? Of our tools so far, we need to find something that's perpendicular to both of these. So find an x um, perpendicular to both.
Right.
And let's just brainstorm for a quick minute. But what do our tools so far, or which one of the tools that have been presented to us is relevant to this problem? The dot product, we've kind of studied a little bit, and we've, kind of talked about how if we have just sort of two vectors, the dot product is zero. But here's a situation where we kind of have three vectors. So the dot product is kind of ill suited for this problem,
Okay.
right? The dot product, um, well, you could do it with a dot product. It's just more complicated. But I would rather steer you towards the other option. Do we know what the other option is? We basically only have two
Take
tools, right?
Well, I mean, we got the cross product, but I thought we take a derivative.
No derivatives yet. We haven't. Right now, how do I put this? Right now, in multivariable calculus, the first two couple of weeks or so are just giving you very, very, very basic tools before you even get to the calculus.
I see.
Right? You're not even ready to learn the calculus until like a month in. We're just
Right.
talking like if you think about all of elementary and grade school as being the preparation you need um, until you can get into calculus, right? Multivariable calculus kind of crams all of that into a month, except for now it gives you a bunch of multidimensional tools like dot product and cross product instead of regular multiplication.
Right.
So, okay, we only have one other tool. What is it?
Um,
Right? Instead of the dot
cross product.
product, we have the what?
Cross product.
Yeah. And do you remember the right hand rule?
I do remember the right hand
Yeah,
rule. I remember
we
hurting
don't
too.
have to we don't have to use the right hand rule too much in this problem, but
Okay.
do you remember just generally if you have u cross v, what does the cross product spit out? Can you just describe qualitatively what you know about the cross product?
I mean, it spits out the k, right? The vector.
Well, let's not use k because k is understood to be the a unit vector on the
The
z-axis
z
specifically, but it does spit out a new vector, yes. And can you tell me
the
anything
z.
qualitatively about the new vector compared to the old ones?
It's in between the two of them, or it's
It
perpendicular to.
is. It is, exactly. The cross product was contrived so that whatever it spits out is perpendicular to both the originals.
Right.
But oh, hey, isn't that exactly what we were being asked to find in this problem?
It is.
Yes, yes. So this problem was essentially just a different way of, sort of slyly asking you, hey, remember that the cross product, this is exactly what it does. It finds something perpendicular to both.
Okay, so that makes sense.
Yeah. Uh,
So we're doing a cross
Sorry, needed
product.
to sneeze.
You're good.
Uh,
So that's we're just it's almost a very simple cross product, just very complicatedly asked to kind of make
yeah,
sure you
it's
understand what we're doing in general.
yes, it's not quite a trick question, but they are sort of strongly hinting at you to use the cross product. You just sort of need to realize that, oh, this is exactly what the cross product was created for.
I
Yeah.
see.
I
Okay.
mentioned that this problem could have been done with a dot product as well. It just would have been probably would have been a huge pain in the butt. But the
Yeah,
idea is
I
that,
didn't quite understand that, but
yeah, the general idea is um, for any given vector, in let's say we're in three-dimensional space, right? And you have some vector u, there's an entire plane that's basically perpendicular to this vector u, right? Every single one of these vectors inside this plane is perpendicular to u.
okay.
Can you
Yeah.
picture that?
Yep,
You're just sort
totally.
of like swiveling it around, right?
Right, like a top.
Yeah, and if so, exactly. So this is basically saying, okay, so we know that u, if we're trying to find some vector x such that u dot x is equal to 0, well, after just knowing this one piece of information, knowing what u is, we have like infinite options for x. Every single one of these things could potentially be x. We need to narrow it down further.
Right.
Yeah. And then if you have some other vector, let's call it v, right? Same deal applies. There's going to be an entire plane of stuff that's perpendicular to v,
Okay.
right? And this is really hard to draw, but you can still picture it's exactly the same
No,
situation
you're
as
doing
before
a
we just
good job.
swiveled,
I can totally see the flat plane
right?
going to the right. Yep, got
Yeah.
it.
And every single one of these is also, uh, you know, every single one of these is perpendicular to v. So then, it's sort of asking, okay, well, which one of these vectors? It's sort of saying like, where does this plane and where does this plane intersect? And that intersection is going to be a vector that happens to be perpendicular to both. Do you see that?
Yes, I do. Yep.
Yeah. And it so turns out that yeah, so if this is u and this is so if u is going upwards and v is going rightwards, it turns out that what these two planes have in common is going to be the vector that comes out of the screen towards us, and also its inverse, the vector that goes away from the screen.
Okay.
Again, I'm using organic chemistry notation where a shaded in wedge means it's coming out to us,
Yeah,
and these kind of like ladder steps means it's going away.
understood. Yep.
But yeah, that's sort of, this would have been a big pain, but I just kind of want to show you that, conceptually, there's kind of two different ways to look at it. Uh, or maybe the dot product kind of, I'm hoping that this explanation of the dot product makes it a little bit more clear how you can find that. Uh, Sorry, excuse me. What exactly it means for a vector to be perpendicular to two other vectors.
Yeah, I mean, I could with the visualization made it a lot easier to understand that.
Yeah, good. Okay, chugging right along. Okay, they're just asking you to compute another cross product that seems very straightforward.
Yep, too easy.
Yep. Just again, make sure you get some practice. If you find yourself, finding it easy now and you're doing it and you're making some mistakes, just make sure to double check where the negative signs go, right, and follow the process.
Sure, yeah, yeah.
Yeah,
I do have that habit of little tiny mistakes, so, but I
yeah.
will do that. But I also have a list of other, written homework problems to practice too besides just this homework, so
Okay, sure.
grinding it out is the plan.
Yeah. For things like getting, nailing down nailing down computational problems like that, sometimes elbow grease is the solution. But sometimes when
Yep.
it's asking a little bit stuff more involved and you're finding that, you're staring at it and it looks like Greek,
Yeah, that
grinding
happens a
it
little
out
later.
isn't always the best option when it comes, when you don't even have that level of understanding yet in the first place.
I'm glad you brought that up
Yeah.
because, like, right now we're still kinda do basic math, but I know because I took this class last quarter that as we get deeper into it, I and other students will get confused in the process,
Yeah.
and grinding it out was my solution that did not help. So, yeah, and
Yeah.
as we go forward, that I'm open to how
Sure.
we get around that.
Right.
But
Okay. So
okay,
find a
yes.
vector u that is parallel to
Yep.
the yz plane and perpendicular to the vector v. Interesting. Okay. So How do I want to draw this? X, Y, and Z. So it's understood that in this particular drawing, X is coming out towards us, okay?
Yep.
And I'm going to use the wedge again.
Sure.
It's like the one takeaway I had from organic chemistry.
Hey, what
Uh,
works?
yeah. So then Z is literally upwards on the screen and Y is literally to the right.
Tracking.
But we're trying to find something that is parallel to the YZ plane. Right? That kind of means like we're looking for a vector that is literally in the YZ plane. So like literally in the plane of the screen, right?
Okay.
Which is saying it doesn't have any inwards or outwards component at all. It is literally living in the screen.
Right.
Okay. And it's perpendicular to the vector, perpendicular to some vector V. I'm just going to make up something else like 1, 2, 3. Okay.
Okay.
Sorry. So if something is, if some vector U is parallel to the YZ plane, this is essentially saying U looks like, it's essentially saying its X component is 0. But then the Y and Z components, we're not sure yet. So let's just call that B and C, okay? For what we're
Okay.
trying to find. Now, what they're saying is it needs to be perpendicular to vector V, which again was 1, 2, 3. So the idea is we need to dot these two things together and choose a value of B and C that make the whole thing 0. Does that make sense?
Yes, it does.
And because there's two, so I'm going to write it out. So the dot product is 0.1 plus 2b. So I shouldn't write a dot. I should just write this as multiplication, right? So I'm just doing the dot product plus 3c, and this needs to be equal to 0. And we know that this is one equation, and there's two unknowns. So from algebra 1 or 2, there should be infinite solutions here. This is actually going to look like a line of solutions.
Okay.
But for our purposes, we just need to find any B and C that make this true. So we can find any B and C that make this 0. And you could literally just plug, you could just do guess and check, really, right? You could literally just guess, okay, what if I just guess B is equal to 1, is there a value of C that would satisfy this? And you can check that, yeah, actually there is. Would you like me to go through and show you, or do you think you got it from here?
No, I think I understand it from here.
Gotcha. Yeah. I mean, at this point, you could literally guess whatever you wanted,
Yeah, right.
right? But they are asking for one thing not to do though is not to use 0, 0. Because that
Okay.
sort of goes against the spirit of the problem. If you do 0, 0, then your vector u is just all zeros. And although they don't explicitly prohibit it, this is usually considered like against the spirit of the problem, right? Like if you're trying to
Okay.
find something perpendicular and you to another vector and you say all zeros, the 0 vector, you're kind of being a
Right.
smartass,
Okay,
right?
yeah.
That's essentially what. So just find a non-zero vector that satisfies this.
Right, makes sense.
That's the idea. Yeah.
Sorry, I just had some, ideas and tests, like, when you just, like, I could not answer the problem, I'll just, like, throw that up as the last resort, but
Yeah,
I
I mean,
won't
what's
do
funny is
that.
that they don't actually prohibit that for this particular problem, and I'm kind of curious now if 0, 0, 0 is going to work, right? Because it satisfies the question down to the letter of the word, but perhaps not the spirit of the problem.
Right. Well, but maybe it's the 1, 2, 3 that numbers that we picked.
What do you mean?
Just I thought the never mind. I'm talking out my butt. I
It's okay.
misunderstood.
Let me put it this way. Uh, 1, 2, 3. No matter what vector v here is, right?
Right.
V could just be any random vector in this 3 space. And remember how we said earlier that there's always going to be some for any vector v, there's going to be some horizontal, or not horizontal. There should be some plane of vectors that are perpendicular to it, right?
Right.
Well, between any two planes, so now it's saying, okay, we need a vector that's both within this plane and within this plane. And
Right.
the question is that always possible? And yeah, intuitively it should be, because between any two planes, you should always get some intersection between two planes, right?
Right, but
two
0,
infinite
0, 0,
planes, so long
is
as
that
they're
the
not
point of
parallel to
origin?
each other.
Right. Okay.
You see
Does that
that?
mean that the 0, 0, 0 is the point of origin? Is that why it's kind of
Uh, other than
maybe
zero
I'm
zero zero.
other than 0, 0, 0,
Yeah,
right,
we're
I
saying
totally
the two planes both have point. What are we saying exactly?
I just meant the reason why 0, 0, 0 is a smart ass because it's the point of origin of the course that we
Yeah,
use,
we're
right?
sort of saying,
Okay,
okay, these two planes both have 000. Sorry, they both contain 000, but otherwise they're oriented differently. Do we still
right,
have a guarantee that there's some non-000 pointer vector of intersection?
sure. Okay.
And the
It
answer
was a
is yeah. Like
math that kinda
intuitively,
went over my head, so
yeah. Like intuitively, if you have two infinite planes and they intersect at one point, 000, right?
right.
Like they're guaranteed to intersect at more points than just one. Can you picture? Like, there's no way to get two infinite planes that intersect at one and only one point. You see what I mean? Like, can you picture that in your head?
No, because now I'm confused because I thought that, like, you could if you just like, I think of a plane like a sheet of paper, right?
Right,
Just
but it's an
a flat
infinite sheet of paper.
right, so if I have something going at an angle, and then okay, you know what? I see what you're saying.
Right?
I do,
Like,
okay,
it's kind of funny. Either they're totally parallel and there's no intersection,
right.
right? Um, or if they're
Have
touching
0, 0,
at
0.
all, then they're going to be touching an infinite number of points.
Right, right, okay, I see that now. I do.
Yeah, yeah. Like,
Okay,
just
my
drawing it
brain
out.
just wow, no, my brain no, it makes sense, it absolutely
Yeah,
makes sense, but sometimes that visualization's hard. Okay, I got
yeah.
it.
Yeah. And this is more, how do I put it? This is probably material that is covered a little bit more formally in linear algebra. But like, I think intuitively, you should be able to picture this after having like a high school math background, right?
Sure, no, and I could do it
Yeah.
with the visuals, but trying to then relate it back to the numbers of vector 1, 2, 3, and trying to
Sure.
that's where I'm just my brain is
Yeah.
spinning.
Okay.
But
I
that's
could maybe
okay.
relate it. But basically, what I'm
I
saying is the fact that they have infinite number of uh, points of intersection, right? And each point, let's say that both planes intersect at some point just out here, right? And we can think about that vector
yeah,
that goes to that point. That's going to be a valid choice for a U. There's going to be a B and C that leads us there.
right.
That's what I mean. And because there's infinite points of intersection, that means that means there's infinite choices for B and C.
B
That's
and
all.
C. Yep, yep. No, that makes more sense now. It took a second for me to, like,
Sure,
get
sure.
there, so
Yeah. Um, okay, keep going. Um,
yeah, no, I'm good with this,
okay. Do you think
after
we're
you
making
did that
pretty good? Do you think we're elucidating things in a reasonably good way?
I really do. I think we're hitting the core concepts that would, grease the wheels without having to actually do the computation to answer the problems. This is all very
Sure.
helpful. I can definitely go back and knock out the computation side of this
Great.
after this
Okay.
session.
So the next time around, they're giving us 3 points, right? Good old, well, I guess instead of a triangle, it's just an angle, but one is A,
Right,
B, and C. And this is in three space, but I'm not going to bother to draw that out. It's just two. I'm just going to
sure.
draw down two, right? And they're asking, okay, between A, B, and is it AC,
Yes.
right? So if you're given points, yeah, you know literally what C is equal to. Sorry, you know
Yep.
literally where C is in space, where A and B are in space,
Yes, yes,
right?
we do.
How would you approach this problem? Do you have an idea?
I mean, make it a magnitude of A and B and A and C.
That's kind of
Mm.
yeah, I mean, you could, but like, yeah, okay, I see what you're saying. Yeah, you're gonna do that eventually. But like first steps
Oh,
first,
I'm sorry.
like,
So we're determining the angle, right?
yeah,
So yeah, so we get the 2 things, we take the angle from it, right?
right.
Which would
But
be
right
the
now, all you know
slope
is
or
like
slope.
literally the right now you literally know the points, right? Like this is A1, A2, and A3. So
Okay.
the first thing you need to do is find vectors, which isn't too hard, right? I think you might have subliminally skipped over that step.
Yeah, a little bit.
But vectors aren't crazy, right? You just subtract them from each other,
Right.
right? So to get BA, you probably just take B minus A.
Yep. Yeah, I kinda skipped over that part.
Yeah, exactly. And similarly for C to get the
Right.
vectors.
Yep. So we get the 2
So
vectors, not magnitudes, the 2
yep, they're
vectors.
actually vectors. Yeah. Once you have the two vectors, well, at this point, this should all be stuff that we've done before, right? Once you know the vector, we'll call it vector A. Maybe let's just call that vector u instead and call this
That
vector v.
helps. I know it's the same, but it does help.
Exactly,
Yeah.
yeah. Once you have vectors u and v, at this point you can just use the dot product stuff that we were just talking about, right? So
Right.
u dotted with v, and again, you literally know what these are,
Yes.
is equal to u and v. You know them because you calculate the vector based on taking the difference of the points.
Yep.
And then cosine theta or cosine theta is what we're trying to solve for, and we know everything else. So
Right.
just divide that over and solve for cosine theta, and then use a calculator inverter if you need. Sorry, trig inverter calculator if you need to. Yeah, I mean, you're probably going to need to use a four function calculator or scientific calculator to invert the cosine, unless it happens to be very easy. But are we all good on that?
We are definitely good on that.
Yeah, okay. Oh, hey, it looks like the problem wasn't even in three space, it was just in two space, but not a big deal. Doesn't really change anything. So, maybe just erase these. Yeah.
Yeah, it's the same. I'm tracking with the same.
Yeah. It's okay. So sketch the triangle with vertices 0, 4, 7, 2, 4, 0. Okay. Or just whatever it is. Sketch the triangle with two vertices and compute its area using cross products. Ah, yes. I need to remind myself how to do this. Wait, what? It looks like they're. Oh, is it understood that for this particular problem, is it understood that vertice O means the origin?
No.
Because it doesn't give you all 3 points otherwise.
Yeah, no. I wasn't tracking that either.
I think that's basically what it's saying here. And this is probably something that they should
Well, that would
communicate
make
better.
it. Yeah, that would make it because this is just like the last problem. Only, well, it is like the way we did it the last problem. But okay, so I do this the same way.
Yes, you need to find the area using cross product. But
Oh, I need the area. Okay.
hold on a
How
second.
how am I doing area?
Uh,
Yeah.
okay. Yeah, let me try to remember myself how to do this. So I got to make the assumption that O means the origin, right? Because otherwise, if you're
Right.
literally not given all 3 points of a triangle, there's just not enough information.
Exactly. So it would have to be.
Yes. But okay, so problems like these, the cross product, I'm trying to remember how to do these. And I'll probably figure it out as we go along. But the cross product, let's call this U and let's call this V. So we can find U, V just like before, right?
Right.
We have 3 points. We can definitely get the vectors. So the cross product, U cross V is equal to UV sine theta, right?
Right.
This is, I don't remember if this is a definition or result, but take this from your textbook, where
Right.
theta is the angle between them.
Right.
And I'm trying to remember exactly. Sorry, I'm trying to remember whether or not this is completely straightforward or if there was a little bit more to it. But
Like, do I assume it's a right triangle and just soak it to it?
no, you can't assume that it's a right triangle. But we can find right triangle structures within it. If we can just find the, what do they call this? The altitude. If we can find the thing that goes from Q to some point along here, such that a little right triangle is created. Well, then we have then we could treat V as the base. And if we just knew the height of this thing, right? If we just call this like H, if we just knew the height of this thing, then we just do base times height over 2, right? You there?
Yeah. No, I'm here.
Following?
Yeah, I am, but I'm also not because
Okay.
I pulled up the practice problem to show like how they did it,
Yeah,
and
no, I remember how to do it. I remember how to do it.
okay.
So I'm drawing it a little bit tilted, but if you want me to untilt it a little bit to make it maybe a little bit more clear.
No. I don't need the untilting. Well, it's
Okay.
up to you, but
Right.
I can orient.
So if I'm just saying let's call B is equal to the magnitude of V,
Right.
and this is U,
Right.
uh, and this altitude that gets dropped down to form a right angle, let's just call this H, and this is theta. If we can just figure out what H is supposed to be and multiply that by, we're saying B is the magnitude of V, the area of a triangle is just equal to height times base over 2, right? So if we can just find H, we're done, right?
Okay.
We just find H, we're done. So then what
Is
is
that
this exactly? What
would
is
that be the cross product?
Yeah, we're getting to it, right? We're getting H is related to U and theta by what is H equal to? H is just equal to the magnitude of U times sine theta, right? So, oh, look at this. This is starting to look a lot like what we have over here, isn't it?
Yeah, yeah, it does.
Right?
Okay, so that's V. That's our vector for V.
Yeah, exactly. So if area is equal to H times B over 2, uh, shoot, H times B over 2, right? And H is just U sine theta. And B, we said B is just the magnitude of V. So that's over 2. And what do you know? This looks almost exactly like what we have over here. UV
Right.
sine theta, U sine theta V, just divided by 2.
Yep. Divide by 2, which is the 1/2 area formula, right?
Yeah, exactly. So what this is saying is that the cross product itself would have given us the area of the parallelogram. That's just sort of two triangles, two identical triangles meshed near each other.
Right.
But then you have it just to get the area of the triangle that you want.
Right. Okay.
Does that
Okay.
seem approachable? So the bottom line
It
is all you have to do is take the cross product, U cross V, which is this thing, and then just divide that by 2.
that does make sense. Okay.
Yeah. And I'm pretty
Yeah.
sure that result was in your textbook anyways, right? Like this must be incredibly
It
standard.
yeah, no, it is a cross as I'm looking at, the way they're doing an example, it's the matrix cross
Yeah.
product, so
But no, I'm
exactly
hoping that just doing like a short video on these things make it more approachable than reading through a textbook.
it does because
I
the way you draw your the triangles, the visuals, and, the shapes, it does put context to
Yeah.
what they're giving here,
Like
so yeah,
a
no,
big
it's
hope of this is um presenting a lot of textbook material in sort of an approachable way. I feel like it's got to help a lot of students. Like textbooks, I don't think are objectively the best way to learn, except for they're just
not
sort of
for
like
math.
how it's typically done, you know? What is this? Find the cosine of the angle between V and W. Oh, we should know how to do this, right?
Yeah, yeah, I know how to do this.
Yeah. Okay, cool.
I mean, we've been pretty much doing these.
Yeah, we've been asked to find the angle, or rather, indirectly, we've been asked to find the angle because we've been asked whether it's obtuse or whatever.
Yeah, we just
Acute.
used a little arc cosine sort of stuff, right?
Yeah, but here it's saying we don't even need to go with the last step of the arc cosine. We can just leave the answer as a cosine theta,
Oh, right.
right?
Well, then I do the first part of those problems, right?
Exactly. So when you have u dot v is equal to u times v times cosine theta, you know
I'm just
all these
looking for my
things,
UV. Yep.
and you just divide them through, and you're good
Yep.
to isolate the
Easy.
cosine theta.
God, this is so much easier now that we've walked through this a couple of
Yeah.
times.
Well, at the end, it's not so bad, right? It's another one where it's just asking you to compute a dot product. Okay, we've done that quite a few times,
Too easy.
right? You just got to always remember in your head which one's the dot product, which one's the cross product. And the dot product is the one that spits out a scalar.
Right. Oh, number 18.
Oh, it's a little bit more complicated, huh? What is it
Well,
asking us?
okay, A, B, and C, and it's giving us the I, J, K. So that means those are vectors. So if I got confused, I can always rewrite those all in that vector format if I
Sure.
need to understand it better. Which pairs of these vectors are perpendicular? Okay.
Right. Okay. So this is gonna, there's not really a fast way to do this. This is gonna require a number of computations. But between
Okay.
just a given pair of vectors, u and v, we know that it's perpendicular. Um, we know that it's the sign that it's perpendicular is when u dot v is equal to 0. And it looks like this problem is just asking you to do a bunch of maybe a bunch of legwork and just trying out every possible pair and just figuring out which possible pairs are 0. Um,
Okay. So one, there's only five of them.
yeah, so that could be up to 20 calculations though, which is kind of a lot. I mean, you can kind of like you might be able to kind of eyeball these a little bit faster. Um,
I was wondering. I wonder if I drew it out, right? Like the little charts that we were working on before, where it
yes,
had if I drew it out.
yeah. Um, let's put it this way: it might be easier to start figuring out which ones are parallel. Because if they're parallel, they're obviously not going to be perpendicular, right?
Right.
And that would be able to let you cross that out that
And
would
they
let you
can
be
have
able to rule out some pairings.
right.
But parallel should be, I think it's a little computationally simpler because U and V are parallel when U is equal to some scalar K times V. I'm really inconsistent about drawing the arrows on these things, but hopefully it should be clear from context.
It
But
is,
it's
yep.
basically if there's some non-zero scalar factor K, and keep in mind this could be positive or negative, right? If there's just some K is basically a stretching factor, yeah. Because
Right.
if U looks like this, um, and you stretch it by some factor K, sorry, I guess it's the other way around. I guess V looks like this, and if you stretch it by some factor K and it turns into something that looks like this, well, they're parallel, right? All K does is stretch or reflect. Reflect is when it's negative.
Okay, right.
Can you see what I'm saying? Like if
I
K
do,
was a
I do,
factor
yeah,
of
yeah, yeah.
2, you're just stretching the vector out by length 2.
Right. Yeah, it's just a scalar, and if
Yeah,
it's negative, it's going the other way.
exactly. If it's negative,
Yep.
yes, right. So,
Yeah, no, that makes sense a lot. I get
yeah.
that.
So I think you basically just got to go through this problem and
Grind it out.
grind it out. Yeah, like maybe the way to just do this systematically is to go through and calculate the dot product between every pair. So if there's 5 vectors, um, that's going to be, what is that? Is that 5 times 4 over 2? That's going to
Yeah,
be, you're probably going to have to calculate it between 10 pairs.
10, right.
Yeah.
Well, I mean, we talked about doing this in repetition over and over. This will
Yeah,
be
it's a
it.
good chance to get some practice, right? And keep in mind that, keep in mind that for the dot product, U dot V is equal to V dot U. But that wasn't
Right.
true for the cross product.
No, it's not, right? That
Yeah. But for this particular product, because we're using the dot product, this saves you some work because if you check U dot V, you don't have to check the other way around. You see what I'm saying? That saves
I
you some
do, yeah.
work. So, what I would do, do you know how to do these problems like kind of efficiently? Like if you need to do A, B, C, D, and why does it go to G instead of E? Okay, whatever.
I don't
Right.
know.
To do every
See if you're
possible
paying
pair,
attention, that's why.
right? To do every possible pair, you do A, you do it like this. But then once you get to B, you don't have to search backwards for A,
Right.
right? Because you've already done that. So just go kind of like if you line them up, just keep going to the right, so that
Okay.
every time you get to a new one, you have fewer to search. So C, you only have to
I
search for D and G.
I was not aware of that sorting methodology, but I am now.
Yeah, no, it's generally a good thing to. It's generally a good thing to know. And keep in mind again, this only works for things where uh, the order doesn't matter. U dot V is equal
Right,
to V dot U. We say that
right.
they commute,
Okay.
right?
They can okay.
If we were doing this, if we were doing something similar for cross product, you would have to check every pair in every order, right? You would have to check both U
Right,
cross V and V cross U.
right.
But yeah, this should just doing that should give you everything, right? Perpendicular when they're perpendicular when the dot product 0, and you also should be able to tell when that's less than pi over 2 and when that's greater than pi over 2 based on the sign, right? We said that less than pi
Right.
over 2 is acute angles and should be positive sign because that they're vaguely in the same direction,
Yep.
right? Dot product is positive. And if the angle is larger than that, the dot product should be negative.
Right.
And yeah. And then
Yep.
the parallel one is maybe a little bit, the parallel one isn't going to be quite as clear from the dot product because it's kind of hard to know when, parallel means that they're, the magnitude is maximized. And that's kind of hard to know just from a calculation. So to find that, you might instead look pairwise and see whenever you might find a stretching factor of K.
Okay.
Right. So basically what I mean by that is if you have like 1I plus 2J minus 3K, yeah.
Right.
And
Yep.
then you saw some other vector that looks like, I don't know, minus 2I minus 4J plus 6K. You just kind of have to like visually recognize these, like, hey, there's a factor of -2 between each of these pairwise terms,
I see what you're saying.
right?
Yeah,
You got
no.
to like
Okay.
compare them up and try to look for that thing.
Lowest common denominator. Yeah, yeah,
Yeah,
yeah. I gotcha.
yeah. But you can save some work. Like if you know some pair is already perpendicular or has, if you know it's perpendicular, then obviously you don't have to check for its parallel because it's not. If you already know that something is two vectors are perpendicular, you know that they're not parallel. Just save some work, right? Yeah, I'm looking quickly ahead. Number 20 is a 3 by 3 determinant. And you just got to look up the process for doing a determinant in your textbook.
Okay.
It's actually extremely similar to the cross product. Um,
Okay, so a determinant is similar to the cross product.
yeah, I mean, you'll
It just
once you do get some elbow grease and do these out, you'll probably see what I mean.
okay, yeah,
Yeah, just look for any feeling of similarity when you're doing it.
okay.
But
And then
for number 19, I'm looking at it real quick, and I'm actually not quite sure what's asking here. But it's giving you some value for V and some value for W, and you don't know the actual vectors themselves. You just know that the angle between them is 0.4 radians. Okay, so V dot W is easy enough. We've done this a billion times,
yeah, that one's easy.
right? But this next one's kind of odd. 4V plus 2W. If they're asking for the magnitude for this thing, this is just a slightly bit tricky, because what this is saying is if we stretch, if one of these is U and one of these is V, and we stretch, how do I put this exactly? If we instead compare like the angle between the 4V, if we, it's kind of hard to know exactly what 4V plus 2W is like, if that makes sense. It's going to be something out here, and
Okay.
it's really hard at a glance to find out what the angle here is. Does that make sense? You know what I'm saying?
Yeah, yeah.
So there is kind of a trick here, and the idea is to remember that this remember the squared thing is equal to 4V plus 2W dotted with 4V plus 2W, right? So if we can find the square of this thing, we can find the actual thing itself, right? Because the
Okay.
square is gonna be a straight up number, so we just square root it.
Okay.
Okay. But it's nice because the dot product lets us express this as the dot of these two vectors,
Ah, I see that.
right? And then we still don't know what V and W are individually, but heck, let's FOIL it out and see what we get, right? So we get
Okay.
something that looks like, um, oh, sorry, I should probably not use these specific numbers.
Sure. Yeah, let's
Um,
do the different number.
like, 5 or 10,
Yeah,
right? So like 5 and 10, 5 and 10. And I don't know, let's make this maybe 0.1 radians instead.
sure.
Like the general process is similar, but just FOIL this out and notice that you get like 25 v dot v plus is it 50 v dot w plus 50 v dot w plus 100 w dot w.
Right.
Yeah,
And then
and
we
at this point you
equal that.
can know all of these because remember what we're given. We're given these three things.
We are given that. Yes.
Yeah,
Okay.
so you can see that you can. These are all genuine numbers, and
Right.
these you just have to square, right? The v and the w
Right.
magnitudes. But apart from that, yeah, this should be all the information you need.
Yep. It's just
See what I
computation at
mean?
that point.
Right, exactly. So, the key to this one is sort of realizing that, okay, if we can't calculate the, magnitude of the, combination directly, let's see if we can calculate the magnitude of the square.
I see. Okay. That was not intuitive for me on the face of it. That's just gonna take me working on it. But it does make sense. I do understand how to do the problem.
Right? That's awesome. Yeah. So I'll cut this
Awesome.
up into a video as well. And yeah, you
Yeah,
said these
this
are
was
due tomorrow,
really
right?
good. Yeah, so it's due midnight tomorrow, but
Yeah.